Here's a shot of zone 1, and the drip line that they use. Normally you'd see drip line that has emitters out where all the water comes out evenly, and there would be a drip valve because the water pressure that needs to flow to the drip zone is greatly reduced from what a regular valve would provide. But what they did here was they just used a regular valve, probably because it cost a fraction as much, and they used regular solid tubing with drip emitters running to all the plants. And the biggest problem with that is that the drip emitters, they get pulled off the line. It's just not the right way to do things. You know, the regular drip lines would go all through the bed, probably at about 18-inch spacing, and get really uniform water. But when you have all these little tiny emitters going everywhere, you don't get very uniform water flow to the different plants and even irrigation coverage. And the other problem is it's just going to fall apart. It's not the quality way to do things. And if this was in the city of Austin where they had to have an irrigation inspection, it probably would fail the inspection. I mean, nobody does drip irrigation, especially at a higher end home, using this, really cheap, flawed way to do things. All right, this is zone 2 back in the dog area. What I don't understand is right back there, why is there a rotor in the flower bed 10 feet away from another rotor? That really doesn't make sense. And you need to look at the precipitation arc coming out of these heads. It's at best, mediocre. And what you should see is head-to-head coverage. That head that's way back there should actually be spraying over and hitting that head. And if you look, it's probably coming up at least 10 feet shy. What they call that is double coverage, where every head should be spraying the head nearest in the zone. And when you look around, you don't have that uniformity that you should have in any properly designed and installed system. Here's zone 3 back in the dog area. This is an MP rotor zone, and the problem you have back here is this zone has what's called single coverage. There should be heads along the fence where you see them, but there should also be heads back here along the wall spraying, so you get double coverage where every part of the yard is being sprayed by 2 sprinkler heads. So what you have in this section here is basically half a sprinkler system was installed, and that creates really ununiform coverage. And even though the runtime right now is set should be more than adequately, it doesn't look good because of the half of a system that was installed here. So what needs to be done here is more MP rotors should be along that wall spraying back inward to get the proper double coverage. Here's zone 4, the trampoline area. And here, it's not quite as bad, but here there's 7 rotors on this zone. The water pressure, it's not horrible, but it's not as good as it should be. And those precipitation arcs are not as good as they should be. 6 rotors is pretty much the norm when you have really good water pressure. So here in the middle area of the lawn, it's really not getting as much irrigation coverage as it should get. This is the front of the house. All these beds are all in zone 5. They all use the same drip tubing with emitters coming off for every single plant, which is not the way that any professional would normally do it. And according to Luciano Gomez, the irrigation guy that I like to use, there's also no drip valve for this front bed zone. It's also been just stuck to a regular valve in an attempt to water as huge of an area as possible with little cost. Where normally you'd have a drip valve, which cost a lot more than a regular valve, and drip tubing running all over the beds. And you probably would have to have at least 2 zones to cover an area this big and have uniform water pressure in that zone. So what you see, I guess we're to zone 6 now. What you see here that is improper, if you did this on an exam to try to get your irrigator's license, they would fail you, is you have to have pop-ups on its own zone, MP rotors on its own zone, and regular rotors on their own zone. They all have different precipitation rates, so you can't mix them, because otherwise you get one part of a yard that's getting more water than the other, which basically means you're overwatering one part of the yard and underwatering the rest of it. So what you see along the wall here, those are MP rotors, and what you see along the bed further down are 4-inch pop-ups. Those should never be on the same zone. If you look down here, you see that head that's about 7-8 feet away from the end of the lawn should be right there, to ensure that you get good even precipitation, but instead it's placed way over there for some reason. Just more issues that need to be rectified. Here I believe we're in zone 7, the front yard. There's 8 rotors on this zone, which is quite a bit. And if you look up at the gate up in that area, you can see the lawn's a little on the yellow side. So there doesn't appear to be very good coverage up here. And I would assume by looking around and panning at these heads in the stream coming out of them, they probably stuck really small nozzles possibly in them to even get 8 rotors to run on one zone, because normally even with great water pressure you just can't do that. The only way you could try to make that happen would be to put really small nozzles that flow less gallons per minute. But the proper way normally is maximum of 6 rotors per zone, because the goal should always be to try to get each zone to water as quickly as possible and not drag things out, because then you end up with a really long run time, which can make it challenging to water the yard properly in one watering cycle. Here's zone 8 along the driveway. What you'll notice here is, first of all, this is not a very wide spot, so normally you'd find pop-ups or empty rotors in a spot like this. And the next issue you'll see is there's heads along the driveway over here. We can look on the other side along the native area. There should be a head spraying back inwards to give us the proper double coverage, but instead there's only heads along the driveway. So you basically have half a sprinkler system that was installed along the edge here, which just creates a really inefficient way of water, which makes you have to overwater to try to get coverage to the areas that you don't normally get as much. And if you look down there by the woods, the very bottom left-hand corner, that rotor's 5 foot inside the flower bed when it should be back towards the edge of the lawn more. And if you look down by the column down there, that rotor also is about 4 feet away from the corner of the lawn. So the only way that's going to get water is if runoff runs downhill behind the head. Or proper placement helps ensure more uniformity in the coverage of the irrigation. Alright, now we're up to zone number 9. And if you look at this slender piece of grass, I mean, this clearly should be irrigated by pop-ups. Rotors never belong in a strip of grass that's maybe 6 to 7 feet wide. So not only do we have rotors being used to water a really small area of grass, we also have single coverage where there should be a head back in here. And the reason this was done was the irrigator probably did not want to have to spend the money to put pop-ups over here and have multiple zones. As we walk around, you'll see the other issue we have with this zone is there are 9 heads on this zone. I mean, if you have a commercial system with a really big water main, maybe you can get away with 9 zones, but in a residential application, there's no way you're ever going to get 9 zones to work. And if you look at these precipitation arcs coming out of these rotors, you'll see what you should see is uniform water coming out of the length of the arc, and instead what you see is water basically that shoots to the end of the arc, where throughout the arc itself there's no water coming out of that arc. So that just creates a really bad situation where you have to run this zone for a prolonged period of time to try to get any water on it. Here's a close-up of one of the rotors in zone number 9. And what you should see is an even precipitation curtain coming down, where if you took a dozen tuna cans and laid them throughout that length of that arc, you let that system run for say 45 minutes, you should be able to take all those cans and measure the depth of water, and it should be equal. What happens in this situation is we have really low water pressure, and these rotors are engineered to run at a set water pressure. So once you get outside of the realm that they're meant to run at, that precipitation arc just does not function like it's supposed to, and what happens is most of the water ends up getting shot to the end of the arc. So you end up with really uneven watering. And the only way to cure that is to take these zones and split them in half and really increase the water, especially since this is all the septic area in the middle, which is a really wide area. I mean, if this is a normal lawn, you'd expect to see a rotor zone going right down the middle, but you can't do that because it's a septic. They just don't allow that to happen. So what really probably should happen is there needs to be rotors right up to the edge of wherever the perimeter of that septic zone with the drip line stops to try to get water as far as possible. By splitting these zones, We can also run the largest nozzle size possible to try to spray the water as far as possible. The only way this area was being kept watered last year and kept green is if the run time was just set for a crazy amount of time, like 2 hours, when 45 minutes is what it should take to water it adequately. Here's zone 10, which is the last zone. We have the same problem with zone 10. Too many rotors on the zone, which depletes the water pressure, so the heads don't spray very far, creates inconsistent irrigation coverage, and the precipitation arc is not good as well. So this zone also needs to be split in half so we can try to get good water pressure. I mean, it's end of April. We're currently running 100 minutes a week of irrigation on this zone, which should be plenty, and it's still just not looking good, where I'm going to have to turn it up considerably above and beyond what any properly designed system should require in the end of April. And if in 100 minutes now, when it's summertime and it's 100 degrees plus, I have no idea how many minutes this zone would require. It probably would be 2 hours of run time, which is just creates a lot of wasted water. By the end of the year, with all the issues in the sprinkler system, the waste could probably add up to maybe as much as $5,000 of wasted water, just because the system wasn't designed or installed very well. And if this was the city of Austin, where they actually do irrigation inspections, if the inspector was knowledgeable at all, he would have red flagged the system, and the irrigator would have had to correct all the changes before he would have passed them. So hopefully all these issues get fixed, and hopefully this video, is helpful. I'm not trying to break anybody's balls with this video, but just trying to point out the issues so that hopefully can be corrected.